Logarithmic function, part 3. In this video, I would like to introduce how to solve the logarithmic equations. Let's see example 7.12. Part A. 4 log x with base 9 plus 2 is equal to 0. How to solve it? By observation, we have one logarithmic function, log x with base 9 only. Then, in general, I will use the definition of logarithmic function to solve it. And I will move all the constant term to the right hand side, so which is equal to negative 2 over 4. Simplify, which is equal to negative 1 over 2. If log x with base 9 is equal to negative 1 over 2, we can use the definition of logarithmic functions. Log x with base 9 is equal to negative 1 over 2. That means 9 to the power negative 1 over 2 is equal to x. I can solve. You can see I can convert a logarithmic function to a linear function. We can solve it because this is, you can use your calculator, this is equal to 1 over 3. So x is equal to 1 over 3. How about part B? Log 2x minus 4 minus 1 with base 3 is equal to 3 over 2. Log 4 with base 3. You can use the previous idea, that means use the definition of logarithmic function to solve these equations. But I want to introduce another technique. You can refer to the above text box. If I know log x with base a is equal to log y with base a, we can imply x is equal to y. And maybe you will ask why, and not very difficult to prove it. Okay, we can change all the term to the left hand side. So left hand side is log x with base a minus log y with base a is equal to 0. Then log a minus log b, we can change to one log only. Okay, log x over y with base a is equal to 0. Then, according to the definition of logarithmic function, log x over y with base a is equal to 0. I know x over y is equal to a to the power 0. X is equal to y. So, how to apply this concept in part B? This is log a with base 3. This is 3 over 2 times log b with base 3. So I need to change to log a is equal to log b. So left hand side, log 4 with base 3 to the log 4 to the power 3 over 2 with base 3. Then apply the concept. Log a is equal to log b. This is a and this is b. They are equal. So 2x minus y is equal to 4 to the power 3 over 2. And then simplify it. This is equal to 8 plus 1 over 2. So x is equal to 4.5. Turn to page 9 for exercise 10. And I suggest you can pause the video first and then do this 4 questions. I will check the answer with you. Part A. 3 log x with base 8 plus 2 is equal to 0. So because I have one logarithmic function and all the term are constant, I will make subject. Okay, make log x with base 8 is a subject and the right hand side is negative 2 over 3. So according to the definitions, I know x is equal to h to the power negative 2 over 3 is equal to 1 over 4. Not very difficult. For exercise 11, part B. 2 log x minus 1 with base x is equal to log 4 with base x. Because we have 2 log, so I will apply the previous concept. I want to change to log a is equal to log b. Then we can imply a is equal to b. So log x minus 1 square with base x is equal to log 4 with base x. Remember, you need to move this square, okay, inside to the logarithmic function first. And then you can imply log A is you can use the concept log A is equal to log B is imply that A is equal to B. You can see I will use the term imply rather than cancel log with base 6. In general, we will not use the term cancel. We only know, okay, log A is equal to log B, then A is equal to B. X minus 1 all square is equal to 4. Take square root on both sides. Remember, we have positive square root and negative square root. So x is equal to 3 or x is equal to negative 1. Here's another solution. 2 log x with minus 1 with base 6 is equal to log 4. I can change to 2 square and then put the square in front of the logarithmic functions. So I can cancel this 2. X minus 1 is equal to 2. X is equal to 3. Maybe your solution like this. You will ask, why I have one solution only? So this solution is incorrect? The answer is no. Why? Because when you solve the question related to the logarithmic function, you need to check your answer. Sometimes we have several constraints for the logarithmic function. Log function we cannot put any negative number into the log function, okay? So you can check. How to check? Substitute it and use your calculator to see left hand side is equal to right hand side. So 2 log minus 1 with base 6. Then I mentioned before, this is log function with a negative number. Incorrect. Okay, maybe you can use your calculator. This is math error. We do not have this values. Then you need to reject the answer. So this method is correct, and this method also correct, but you need to check your answer. And sometimes I will also put this 3 into the equation, but obvious, okay, log 6. If I substitute back 3 minus 1 and then this square, okay, put it back into the logarithmic function, that means log 4 is equal to log 4. They're equal. If you haven't finished question C and D, you may do it first. Okay, you can do question D first. This question is a little bit easier because this question you need to change the base. Remember, pause the video and check it later. Part C and Part D. This question you may need to apply the formula of changing base. But do you remember the shortcut method? Log x with base 3. If I want to change 3 to 27, I know 3 to the power 3 is equal to 27. So next step I can write down log 27. Log x to the power 3 is with base 27. They're equal. If you take curve to the base, you also need to take curve for the values of x. And then now the base are equal. I want to change and move this negative 4 to the right hand side because this term without any logarithmic, it's not a log function. So apply the property log A plus log B. We can change to log A times log B, x to the power 4. Because we have one logarithmic functions, I will use the definition. I know x to the power 4 is equal to 27 with to the power negative 4. Log A with base B is equal to C. B to the power C is equal to 8. Then x is equal to 1 over 27. Part D. This question you may have several methods. For example, maybe you can move this term to the left hand side by subtraction and then use the property minus. That means we can change to log A over B is equal to 1. Then you can also solve it. In other way, you can change this 1 to log 10. Then this 3 term related to log, I can apply the logarithmic functions at the property log m plus log n is equal to log m times n. Then log A is equal to log B, we can imply A is equal to B. Solve it. X is equal to 0. This question is similar to the previous one. Remember, check your answer. When you substitute back, obvious. X is equal to 0, this is log negative 10. No solution, math error. So remember, reject it. So what's the solution of this question? The answer is no solution. We cannot find any values of x satisfy these equations. The answer is no solutions.